So, ideal gas law equation, general gas equation, number 1. Number 2, we have the Dalton's law. The Dalton's law of partial pressure. Okay, Dalton's law of partial pressure. Dalton's law of partial pressure, right? You remember that one? Okay. And we have also the, the Avogadro law. Avogadro law, okay. And then we have also the relationship of the Henry's law, but we will not go too much with that. Let's escape that one, okay? Charles' law, let's escape also for that. That's more on physical chemistry, right? And then we do the Boyle's law, like that, okay? Boyle's law and Charles' law, okay? Gay-Lussac's law, okay? Doon kayo siya guys, no? So 5, 6, Gay-Lussac's law, and then we have also the combined gas law, okay? Combined gas laws, okay? Actually, we have also the van der Waals, okay? Non-ideal gas law, but we are talking of ideal man siya, so it's not covered here, okay? Right? And then we are not dealing also the study of the intermolecular forces of attraction on the molecular forces. That's why we omit the van der Waals equation of non-ideality of a gas. It's only ideality of a gas. Okay, so ako na papasok guys. Okay, so the first thing to do guys, when you look at the problem, you need to obtain the physical properties. Okay, the physical properties I teach you, the temperature, the pressure, the volume, highly measurable, okay, like that. Get the point? So, extensive property and then extrinsic property. Physical property talaga siya. Okay? Like that. And then, for example, in this problem, we go directly guys ha? Okay? Okay. Sikog yaw-yaw, mahurot akong oras. Okay? So, a 250 milliliter sample of argon gas has a pressure of 1.25 atmosphere. See? Pressure. See? Physical property, right? At 300 Kelvin, again, another physical property. Calculate the new pressure if the temperature is increased to 500 Kelvin and the volume is decreased to 100 ml. So what comes on your mind? There will be an initial and there will be a final. Things like this, a problem like this is very obvious, okay, in meeting this kind of problems. In the future, final, initial, and then if we reduce, we'll increase. So there's must be a initial state, final state, okay, ganun siya. Okay? So klaro kayong presentation sa problem. It will be your first analysis. Now, you take a look what are the quantities involved. Okay, for example, this one, pressure, temperature, volume, like that. Since I said a while ago, initial, final, I will say P1, T1, V1. Okay? And I will also say P2, T2, V2. Talking about the final, meaning to say the new pressure. See, it's here. Calculate the new pressure, meaning the final pressure. Okay? And then increase to 500 Kelvin. So, and then supply the data. Okay, P1, 1.25 atmosphere. 1.25 atmosphere. T1, 300 Kelvin, like that. 300 Kelvin. V1, imo dyan pangitaon permi. Okay, 250 ml. Okay. P2, calculate the new pressure if hour required. So put question mark or put an X. Or put simply P2. Okay, it depends on you guys, ha? Because you can let that as an pressure 2 as an X if you use a little bit of algebraic expression in our computation. But it's better to use directly the variable understood here, the P2, okay? It's up to you. You can let any kind of letters. The important is you understand. Okay? Like that. So T2 is 500 Kelvin. Okay? And then the volume is decreased to 100 ml. So from 250 ml, the volume is 100 ml. Okay? So it's very clear guys that this is compression. Okay? Because the volume is being decreased to 100. This is a compressibility operation, not expansion. You get the point? It's being compressed to 250 ml, 200 ml, something like that. Now, you need to look to those gas laws where this applies. Okay? Since there are three, P1, T1, V1, so you will match that there in the gas laws. Could it be an ideal gas law, the PVNRT, the Charles law, the Gay-Lussac's law, okay, the Boyle's law, the Avogadro law, the Dalton's law, the Pascal's law, of partial pressure, blah, 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 so and so. So it's very clear that there's a lot of quantities. Okay? So how many quantities involved? 1, 2, 3, 4, 5. And then you will also say, we can also use the PVNRT. But PVNRT is only one general. There's no initial and final. Okay? So it would be better to use the combined gas law. Anyway, the combined gas law is coming also from the PVNRT when you derive that one. Okay? But we go directly so that we will not be able to consume time a lot. Okay? How to derive the combined gas law, that's coming from the PVNRT also. Okay? Now, there are two versions of the combined gas law. Gamera juga akong whiteboard guys, hindi ko maka-express too much. Wow. Okay? So, we think directly the formula without using the conversion and dimension analysis because it's very clear na talaga siya. Don't use the conversion, ha? It's very clear naman siya na we will use standard formulas and equations to solve this kind of problem, not the conversion dimensional analysis. Okay? Because if you use basis of calculation here, there's a lot of basis of calculation here. You will be misled and troubled if you use the dimension analysis way of calculation. Okay? You get the point. Okay. So this is using the ideal gas law, but combined already. Combined gas law. Combined ideal gas law. Okay, when we say combined gas law, that would mean combined ideal gas laws. Meaning to say, these are all ideal gas laws. Can you see, let's say, Dalton gas law, Dalton's law, partial pressure, Pascal's law, Charles' law, Gay-Lussac's law, Avogadro, ganon, Avogadro laws. Okay? So, mga ideality ni siya. Di ni siya applicable sa non-ideality of a gas. Because non-ideality or non-ideal gases are exclusive to van der Waals equation. Okay? So, that's why we need to study also the opposite because it will come out also in the board examination. Sometimes the opposite, not only the ideal gas. Okay? We will not only one-sided. If we will study the actor, we will study also the enemy of the actor, something like that. If we understand peace, we will also understand war. If we understand black, we will also understand white. Okay? If we understand good, we will also understand bad. If we understand beautiful, we understand also ugly. So the opposites. Okay? But what happens, we take for granted the opposites in our study, in our education. We always focus because of that one thing because our instructors and mentors are always focusing on that area. You get the point? So as a student, we need to expand more. Always, I keep this always every time to teach you and to guide you because I've been doing this when I was in college. Okay, so you need to expand out from the backs, go out from the backs in your classroom instruction, go to the library, go to the larger scale of study like that, so that you will be challenged. Because if you are keeping dependent on the examples, oh my gosh, it's always like that every time. Okay, you need to take a look what are the modifications in your future, like that. It would be enjoyable. Me also, I don't like mathematics because I'm not good in math. But because of that ability, then I start to love math. Okay, and then it enables me to learn a lot also in math, even though I'm not good in math. Something like that. Okay. So we have to use the formula here. Okay, P1 V1 over T1 is equals to P2 V2 over T2. So what involves here? Pressure, volume, and temperature. Now guys, there's also another version for this, and we may wonder why why we don't use the another version? And there's a story for that. Okay, actually this is P1, V1, T1, N1. P2, V2, T2, N2. Okay, and then most of the calculations, if we remember in our general chemistry lecture, we eliminate the number of moles in the denominator. Why? Because we are assuming that they are all 1 mole of an ideal gas. Okay, meaning to say, it doesn't change the number of mole. We treat that as an ideal gas, so no need to put the N1 and N2. We will cancel that immediately without carrying that in our formula. So it will become now P1 V1 over T1 is equal to P2 V2 over T2, because assuming that the number of moles are constant all throughout the process. It will never change. Something like that. That's the concept. That's why the number of moles are being removed. There's a reason behind. And the student must understand that also. Okay? Because if you try to derive this from PV and RT, the PV and RT has N, right? Number of moles. So pressure, volume is equals to the number of moles times the universal gas constant times the temperature. So what happened to the number of moles? Why you eliminate that one? There's a reason behind why you eliminate that number of moles. Because we assume that the ideality of the gas is at steady state flow. And then assumption that it doesn't depend on the number of moles because the number of moles doesn't change throughout the process. That means constant. And then we have to eliminate that one. Okay, if you put one, still one on the other one, 1 mole. Because an ideal gas is only 1 mole of an ideal gas, always our basis. Something like that. Okay, in talking about an STP ideality of the gas. Okay, ganon. So magsubstitute na ka chupa-chucho. Okay, ganon. So pressure 1. Okay, 1.25 atmosphere. Okay, ganon. 1.25 atmosphere. Volume 1. Okay, ganon. 250 ml. Now guys, it's in here guys, you have to check the compatibility of the units. Okay, because ml doesn't connect in ideal gas law, because in the ideal gas laws, liter is always used, not the milliliter. So we need to convert first the milliliter before substituting, or we need to convert that milliliter in your incorporation in your formula here. There's 2 ways. But for me, as a student before, I will convert that first before I will substitute to the standard equation and formula so that it will not create confusion for me. Something like that. So by visual estimation, 250 ml, just move 3 zeros in the left. It will become 0.250, right? Okay. 0.250 liter. Okay. Temperature 1. Kelvin. 1,300 Kelvin. Because guys, in ideal gas law or in the ideal gases, okay, that capital T there is the Kelvin, otherwise specified. But most of the times, Kelvin talaga yun siya. It depends on the situation because sometimes also, magkabuang na ganina ang question, even though we have the concept that the T is Kelvin, but still the author of the questions will still ask for Celsius. You get the point? And then all you have to do is to convert that from Celsius, or you substitute the Celsius there. But be sure again that there's a consistency of the units you use there, so that the Celsius will be cancelled also. But it's difficult because the universal gas constant doesn't carry a Celsius sign of temperature. It's always the Kelvin. That's why the capital T there is always the Kelvin. If there are choices in Celsius, then you have to convert the final temperature. Something like that. Okay? So, it's gonna be like that. So, pressure 2. Baka itong ipangayo. P2. Volume 2. O, ganon. So, 100 ml. So, 0.100 liter. Ganon. Okay. Now, temperature 2. 500 Kelvin. So, Kelvin na siya. Okay. Cancel. Tuk, tuk. Ganon. Atmosphere, liter, Kelvin. Tuk, 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 tuk. What is left is the atmosphere. So, calculator, please. Ganon. But be careful with the conversion because sometimes mabuang ang question, the choices will not be there. The units are not there. For example, how many torr? Ganon, nakakaloka. Then the given atmosphere, you have to convert. Okay? But the only most problems based on my experience, they will mix every time the pressure atmosphere here, the bar in the second, like that. But it doesn't matter as long as you have in your mind the compatibility issue of the units. Right? I-focus na lang imong brain cells that it should be compatible or compatibility of the units, and bingo, you can solve everything through that, the consistency, okay, of your units of measurement. Okay, that's very clear, right? Okay, we need to crisscross this one because this is fractional way of solving, right? Crisscross in algebra. Okay, ganon. Okay, so saan na to siya? So, i-times na to ang 0.100, ganon. Okay, times 1300, ganon siya, chupa-chuchu, diba? Okay, 1300. 100 ang Kelvin yan. No, it's not 300 Kelvin lang siya. Okay. Be careful also with your erasures, ha? May mo na akong weakness sa una, guys. Very fast. And then, the writings. Okay? Sometimes, I will be confused. And then, badin, I will be wrong. Okay? But if I try to be, because I'm afraid I will be catched by the time. Right? Because time framed. So that's why I do it a little bit faster. But that's the wrong mentality. You should do that, properly, like this. So anyhow, that's already happening. That's already happened in the past. I cannot do about it. Okay? So 100 times 300 siya. Magbulutaw dyan ko na akong witness ba during the solution, in my discussion. Diba? Bulutaw yun siya na mo din akong kasagaran mistakes. And then you have to admit mistakes, ha? Okay, if you are true professionals, you have to admit mistakes technically. Instead of defending, you should accept also. Okay? Because that's a true character of a human being, to accept mistakes. You get the point? Okay. That's why I don't trust political leaders that will not accept mistakes. Okay? That's an obvious and a very clear mistake. Sometimes you have to admit. Okay? Because it tells you to be honest and true to yourself. That's why I don't like those kind of people that commits mistake in the public speeches and then they will defend instead. So, I'll never salute them. Because a true professionals will discover their weaknesses also, not only the strength. You get the point? So that would be the basis of a strong leader. Okay? He knows his mistakes immediately and he will correct that immediately to become strong. That's very clear, right? No need to expand. Okay. So, 30. So, like that. 500 times 1.25. Like this. Ganun siya, no? Okay. Times 500 pa siya, guys, no? And then divided by 30 siya, guys. So, 520 atmosphere is the answer. 5.20 atmospheres. Now we need to prove this if it is correct or not. It's not enough. Why? Because sometimes due to our errors, we commit mistakes. Right? So the only way to prove that is to have the theory, the relationship. Now, if we have this P1, V1, okay, over T1 is equals to P2, V2, T2, right? Consider the situation here. If you have 1.25 atmosphere and the new pressure, what will happen? Okay, now take note of your equation here. Does the pressure is dependent with the volume? Like this, chupa-chucho, right? Does the pressure is dependent with the volume? Does the volume dependent with the temperature? Something like that. Okay, take another quantity. Let's say 250 ml. Okay, the 250 ml will increase to 100 ml. Right? So meaning to say, your volume 1 will increase. Take note the relationship. Okay? It's gonna be like this in science. You need to be technical in the relationship because that matters a lot. How logical your answer really is. It's not enough solving like that. Okay? Really? That's what I've learned in my 5 years of BS Chemical Engineering. It's not enough to solve. We need to understand what happens after passing to this heat exchanger and after that going to another pipelines. So in that way, you can really, understand what's happening. You can really picture out. Okay? Something like that. Okay, so if the volume 1 is 250 ml and the volume 2 is 100 ml, so it's decreased, right? Obviously. Now, take a look with the pressure. We need to take the pressure because we are asking for the pressure to validate our answer. Okay, P2. Okay, we have also P1. Our P1 is 1.25 atmosphere, and our P2, we obtain already is 5.21, and then it's increased. Okay, the pressure is increased from 1.25 to 5.21, and then the volume is increased also. Meaning to say, it is directly proportional, the pressure and the volume, dependent with each other. If I will increase the pressure, for example, if I have this coffee in my hand, actual demonstration, like that. If I have a volume here, let's say liquid lang siya because I cannot capture the gas right now because I'm not a device, right? So liquid is the most example because this is a very obvious. I put water here and apply pressure pushing the water, right? So if I apply more pressure, what will happen to the volume? Like that. Okay? Nakakaloka, di ba? So, sa may mahitabo, ang higayuna. Okay? So, ni-increase ang imong temperature, right? Okay, imong pressure ni-increase to 521. Ang imong volume po ni-increase. Ni-decrease. Inahim naman siya 100. Okay? Okay, 100, di ba? So, meaning to see, guys, okay, nalibat na po ko, guys. Sorry ha, akong mata. Okay, nagtuo ko 1,000. Okay, like that. Okay, so there's something wrong with my vision. Palusot. Actually, guys, no, my normal mistakes really is the, eyesight. It's not really more on the brain cells. In the eyesight and in the way I write, sa mga erasures. Muna kasagalan ako mga mistakes when I was in college. Okay, but not on the brain cells. Not on the, formulas, equations. But usually, nikasulat ako, masipyat ko, lagi ang akong mata, tungkol sa kapaspas, nga na bitaw, muna ako mga mistakes, guys. Okay, I don't want you to follow me, ha? Okay, write it clearly and properly, ganon. Sa katong wala pa yung mga eyeglass, makaklaro ba yun mo sa mga numbers, okay? Not the same with me, because, nalipat, nagod ko sa 100 God. So, 1,000, napunan ragod na akong 0. Okay, in case like that, okay? But the concept is still in my brain cells. Okay, like this. So if that is a volume 1 is 250, gamay siya. Meaning to say, if I will apply more pressure on the liquid in this glass, the volume will decrease. Meaning to say, the pressure and volume is independent with each other and inversely proportional with each other. The more the pressure will increase, the more the volume will decrease. Okay? So they are not the same. Okay, in magnitude relationship. Remember this because this will hold through also in another higher science subjects. The pressure and the volume is inversely proportional with each other. If you increase the pressure, the volume will decrease. If you increase the volume, the pressure will decrease. And our answer is correct because our pressure is increased while it is lower at first because our volume is being decreased in this problem. And perfect. The answer is 5.20 atmosphere. Any questions so far for this combined gas law equation and problem solving? Kaya ako na siyang papason, guys. Charot. Okay. So, papason na to. So, this is combined gas law. Thank you so much for watching this live streaming. Okay, I hope you like it. You can comment, like, and share, and you can subscribe my YT channel, and you can click the notification bell for some newest updates of I Am a Singer, Eternal Voice. Bye-bye, God bless everybody! Okay. Pero sa akong FB live streaming, stay full. Okay? But my YT, kalas. Oh my gosh. See? Now we go to another topic.